The nearest neighbor of the Earth. The Moon is a rocky, dry, barren sphere about a quarter the size of Earth. This is the only world other than Earth that man has stepped on, and it is a ready and obvious goal for space exploration. The Moon and the Earth are locked in each other's orbits. This means that the duration of a Moon's rotation around itself is equal to the duration of the Moon's rotation around the Earth. As a result, only one side of the Moon is always visible from the ground. The low gravity of the Moon means that the Moon has a very thin atmosphere, and most of the water that has reached the surface of the Moon from its inner layers has evaporated and scattered in space. Because the Moon does not have a strong atmosphere, the Moon's temperature in the equatorial regions fluctuates around 280 degrees Celsius during the day and night. Origin of the Moon. Astronomers believe that a huge protoplanet the size of Mars collided with us when the Earth had just split into two layers of molten iron core and rocky surface mantle. The collision scattered hot rocks and boulders into space, forming a ring of material around the Earth. These materials gradually came together to form a new world in Earth's orbit, a world we call the Moon. This theory explains well why the Moon lacks iron and was closer to Earth at the beginning of its creation. The theory also explains why the Moon quickly became orbitally locked and why its outer layer turned into an ocean of magma at the very beginning of its formation, losing much of its constituent material. The formation of the Moon is as follows. Number 1. Asteroid impact on Earth. A massive asteroid colliding with Earth, about the size of Mars, causes a massive explosion. The collision of such a massive object with one of the inner planets is rare, and it explains why Mercury, Venus, and Mars do not have large moons. Number 2. Materials are dispersed. A few percent of the Earth's mantle material is thrown into space, but most of it returns to the planet's surface. Some of them escape the gravity of the Earth and form a cloud of rocks around the surface of the Earth. Number 3. Materials in Earth's orbit. The particles in this cloud form a ring-like structure around the Earth. Unlike the ring around Saturn, the Earth's ring is remarkably dense. At the same time, the ring was formed where the Earth's gravitational force was weak enough to collide and combine instead of breaking. Number 4. Formation of the Moon from materials. The size of the largest pieces in the ring became larger as a result of the collisions, the frequency of the collisions decreased, and the temperature of the material decreased over time. Finally, after tens of millions of years, only one large object called the Moon came into being and replaced the cloud ring. Moon surface. There is no wind on the surface of the Moon and no news of water or weather currents. The surface of this Moon has been formed over time by collisions of asteroids and meteorites. The collision rate peaked about 4 billion years ago and has been declining at the same rate ever since. At that time, the Moon was hotter than it is today, and just below its surface crust was an area of molten material. Large impact craters tore through this thin crust, and bottom magma flowed over the Moon, covering low-lying areas with basaltic molten material. Circuit and rotation. The Moon orbits the Earth in an elliptical orbit, which at its peak is 10% farther away from the Earth. Its orbital plane has an angle difference of 5.15 degrees from the Earth's orbit. For this reason, the time of the Moon's rotation around itself is equal to the time of its rotation around the Earth. The size of the Moon. The Moon has a spherical appearance, 3.7 times smaller than Earth, has a mass 81 times smaller than Earth, and the Moon is 1/6 of the Earth's gravity. The equatorial diameter of the Moon is 3,476 kilometers, while the equatorial diameter of the Earth is 12,756 kilometers. The structure of the Moon. The Moon's crust is made of calcium-rich rocks, and its mantle is full of silicates. The occurrence of moonquakes raises the possibility that there may be a molten region around the solid core of the Moon. The inner core of the Moon is made of solid iron, the outer core is made of molten rock, and the mantle and the Moon's crust are made of solid rock. Moon atmosphere. The Moon's 25-ton thin atmosphere is made up of radioactive decay, meteorite impacts, and solar winds absorbed by the Moon. 29% of the Moon's atmosphere is neon, 25.8% helium, 22.6% hydrogen, 20.6% argon, and 2% other gases. The average surface temperature of the Moon is -20 degrees Celsius. Asteroids and comets are still colliding with the Moon, creating new craters. Still, the number of collisions today is so small that we must wait about 40,000 years from Earth for an asteroid to collide with the Moon to create a new crater 1 kilometer in diameter. Now, if you consider the state of the Moon and the cloudiness of the Earth, the chances of us being able to see such a collision after 40,000 years would be 1 in 8. A hemisphere closer to Earth. The Moon locked itself in orbit around the Earth at the beginning of its history, when it was much closer to Earth than it is today. Since then, the Moon has been orbiting in a position whose periodic rotation is exactly equivalent to one periodic rotation. As a result, there is always a hemisphere of the Moon facing the Earth, known as the near half of the Moon. But instead of always seeing 50% of the Moon from Earth, we can observe 59% of it. This is the result of a phenomenon called libration. This phenomenon is because the Moon orbits the Earth in an elliptical orbit. When the Moon is closer to the Earth, it moves faster in its orbit than when it is farthest from the Earth, allowing us to see some parts behind the edge of the nearest hemisphere. Furthermore, since the axis of the Moon's rotation around itself forms an angle of 6.7 degrees with its orbital plane, depending on which pole of the Moon is toward the Earth, we can see a small distance from the distant half of the Moon. Size in the sky. The distance from the Earth to the Moon varies because the Moon orbits the Earth in an elliptical orbit. When the Moon is at its perigee, it is 10% closer to the Earth than its apogee. This change in distance from the Earth also affects the apparent size of the Moon in the Earth's sky. In each phase of the Moon passes through its perigee, which has the largest apparent size, and after 2 weeks reaches its apogee, which has the smallest apparent size. One common phenomenon that many people have observed is that the Moon is larger near the horizon at sunrise and sunset than when it is in the middle of the sky. But this phenomenon is just a visual error. Our brain is deceived when the Moon is on the horizon and thinks that the Moon is bigger because it is next to the field of view. But as the Moon rises in the sky, the Moon is seen against an empty background, making it less comparable to other objects and looking smaller. The Moon and Sun in the sky are about the same size. Of course, in reality, their dimensions are very different. The only reason we see these two objects in the sky about the same size is pure coincidence. The diameter of the Moon is about 400 times smaller than the diameter of the Sun, but instead, it is 400 times closer to us. For this reason, when the Sun, Moon, and Earth are in the same direction, the Moon's disk blocks the Sun's disk and prevents its light from reaching the Earth. This happens more completely and longer, when the Moon is in its perigee and its apparent diameter is greater. When the Moon is at its orbital apogee, parts of the Sun may not be covered. Under these conditions, the eclipse occurs, and the shadow of the Moon falls on the Earth. Those in the dark part of the shadow will see a total solar eclipse, and those in the semi-shadow will see only a partial solar eclipse. The time when the whole Sun hides behind the Moon is the total solar eclipse time. Lunar eclipses also occur when the Sun, Earth, and Moon are in the same direction, and the Moon has entered the Earth's shadow. In this case, the Moon is seen in copper red. Towards the Moon and back again. On May 25, 1960, then U.S. President John F. Kennedy vowed to land a human on the Moon before the end of that decade. This goal was achieved 5 months before the end of the deadline announced by Kennedy, and by 1972, 5 manned missions had landed on the Moon. Apollo missions. 12 astronauts were sent to the Moon's surface between 1969 and 1972. All these missions were carried out in the form of NASA's Apollo project. 3 revolutionary ideas shaped this important project. 1. The Apollo spacecraft was designed so that they could drop any part of the spacecraft that did its job, eventually reducing the overall weight of the complex. 2. Instead of the spacecraft going directly from Earth to the Moon, it had 2 parking orbits around the Earth and the Moon, during which the astronauts could carry their equipment to the next stage to prepare for the voyage. 3. The voyage crew was divided into 2 groups when they reached the Moon's orbit. 2 of them landed on the surface of the Moon, and the 3rd remained in orbit and the command module. The Saturn V 3-stage rocket launched the Apollo crew into space. The launcher's final floor lit up and sent astronauts to the Moon. When the spacecraft approached the Moon, it orbited the Moon. The 2 astronauts landed on the Moon with the help of a Moon's module, then returned to the Moon's orbit using the ascent section, where the service module was located. At the end of the 3-day return trip to Earth, the service module was dropped, and the command module landed on the ground with a parachute. Each of the 6 Apollo 11, 12, 14, 15, 16, and 17 missions took 3 astronauts into the Moon's orbit, landing 2 on the Moon each time. After a 3-day journey from Earth to the Moon, the Apollo spacecraft turns on its landing engines and orbits the Moon in an elliptical orbit. At this time, the Moon's module was separated from the 2 service and command modules and gently placed in an orbit that would raise it to a height of 13 kilometers above the Moon. After a final review by the Houston Mission Control Center, the crew was allowed to continue the mission and land. Apollo 13 could not advance to this mission stage because before Apollo 13 entered orbit around the Moon, an explosion in its oxygen capsule forced them to orbit the Moon and return directly to Earth. Great care was taken to select the appropriate landing site for the Apollo missions. The module's security landing on the Moon's surface and its 2 crew members was crucial. However, whatever amount of preparation and planning was done, it still could not cover everything. The success of the historic Apollo 11 landing, dubbed the Eagle, owed much to its skillful piloting. The place chosen for the Apollo 11 landing was the Sea of Tranquility. The sea is the bed of a large collision crater filled with lava material. This place was chosen long before Apollo 11 went to the Moon. The landing time was also carefully chosen. It should be noted in the choice of landing time that the temperature of the moon's surface changes dramatically during the moon's days. For the lunar module to be located in an area of the moon with good temperature conditions, it must land on the moon's surface early in the morning or at sunset and stay there for 3 days. Inside the Eagle's lunar module were Neil Alden Armstrong and Buzz Aldrin. The mission's third crew, Michael Collins, remained in the service and command module, circling the moon every 2 hours. When Eagle started his landing engine and lowered his altitude, Michael Collins followed his colleagues through radio frequencies. As Eagle approached the predetermined landing site, Armstrong realized that the area was full of small bumps that had never been seen before, so he took the moon manual and guided Eagle to a safe area with lead. With only 20 seconds of fuel left to land, Eagle finally landed on the moon. The Eagle spacecraft landed 6 kilometers away from the predetermined location but within the same predetermined target area. When the astronauts were scheduled to rest, they were allowed to prepare for their first space travel on the moon at their own request. 6 hours and 21 minutes after landing on the moon, wearing their spacesuits, Eagle astronauts reduced the cabin pressure and opened the module outlet. While millions of people watched the moment live on television, Neil Armstrong stepped out of the window. He stepped on the ladder attached to the Eagle to become the first human in history to set foot on a world other than Earth. After uttering his first words from the surface of the moon, he began collecting samples of lunar soil and putting samples of that soil in a pocket on his space pants. Armstrong and Aldrin spent 21.5 hours on the moon and 2.5 hours outside the spacecraft on the moon. The last 3 manned missions to the moon, Apollo 15, 16, and 17, each carried a rolling moon named Rover. These cars were 3 meters long, 2 meters wide, and 1 meter high and were about the size of a Volkswagen Beetle. The car was attached to the body of the lunar module and sent to the moon, and there it was detached from the body and opened on the surface of the moon. Using these vehicles, astronauts could explore 10 times more easily than on foot. The cars were made of aluminum tubes, lightweight, sturdy, and equipped with 4 shock-absorbing wheels with titanium treads. 2 36-volt batteries powered the car. The car weighed a total of 208 kilograms. It could carry 2 astronauts with communication and scientific equipment and a camera stand, which weighed 3 times its weight. At the same time, there was still room for a 27 kilogram sample of lunar soil that was to be returned to the spacecraft as a sample. When the car is fully loaded, it could cross a cliff 30 centimeters high, climb a 25-degree slope, or make 45-degree turns. Its circumference was only 3 meters in diameter, which made it a tool with high maneuverability. The device was designed to travel more than 90 km/h at a speed of about 18.5 km/h. The astronauts were told not to travel more than 10 kilometers from the landing site of the lunar module on the moon. If the car had a problem for any reason, they had to return to the lunar module before running out of oxygen. The farthest distance they traveled in one stage was during the Apollo 17 mission. In December 1972, they traveled up to 7.6 kilometers from the landing site. The unseen face of the moon. In October 1959, the far half of the moon was first photographed. Since then, astronauts have been able to see the landscape with their own eyes, and orbiters have explored and studied it. The Soviet Luna 3 spacecraft was the first instrument to image the other hemisphere. The spacecraft captured the moon while crossing it for 40 minutes with the help of a twin camera equipped with two lenses. One lens captured the full image of the moon, and the other lens captured more close-ups. At the end of the photography, the negatives were to be processed, stabilized, and dried on the spacecraft's deck, then scanned, and then transmitted to Earth using a device similar to a fax machine. Astronomers were surprised to see that there was no mention of massive dark seas in the hidden half of the moon. The Apollo 8 crew were the first humans to see the scene with their own eyes during a lunar flight in December 1968. The moon's crust today has an average diameter of about 50 kilometers. But in the other hemisphere, the crust is about 15 kilometers thicker. This difference is due to events that occurred on the date of the moon. About 4.5 billion years ago, the moon was closer to Earth and locked in orbit, coordinating its rotation. Over the next 200 million years, the moon gradually cooled to form its rocky crust. But the Earth's thermal and gravitational effects caused the moon's crust to become slightly thinner in the hemisphere, which was constantly facing the Earth, and to cool at a slower rate. Until about 3.9 billion years ago, the moon was constantly bombarded by asteroids, and both hemispheres looked the same. Then, between 3.9 and 3.2 billion years ago, the balance between surface cooling, in-moon radiative heat decay, and crustal growth caused the moon to enter a period of volcanic activity. Since then, the appearance of the two hemispheres of the moon has changed.